Hello and welcome. In this video, we are going to take a look at how to use Matlab to parse an IPv4 address. The idea here is that perhaps you're trying to parse some command line output or maybe the contents of a text file looking for patterns that match an IPv4 address. This video assumes a couple of things: that you have some understanding of what an IPv4 address is, as well as some basic understanding of the uses of regular expressions for pattern matching. And so to begin with, let's take just a second to look at the definition, or rather the pattern associated with an IPv4 address. Essentially, it is a 32-bit representation blocked into or parsed into 4 octets. And so you'll see here as an example, we have a 192.0.2.235, as well as our local loopback address of 127.0.0.1. Now, there are a couple of representations of an IPv4 address. The only other thing I want to mention is that they can have values that range from 0 up to 255. And the idea here is that we want to match any IPv4 address as long as it follows this representation. The other thing that I want to point out is the use of the regexpi function in Matlab, and particularly the table associated with the meta characters. The idea here is that the regexpi function can help you look for patterns that match this meta character language, if you would. And so the idea here is that we want to look for a numeric digit, in other words, any value between 0 and 9. And we will also use the period, but we won't use it directly as a meta character. We're actually going to see how we can explicitly look for a period. The period by itself in MATLAB's regular expression is going to be any single character, including white space, and we explicitly want to look for the period itself, and I'll show you how to accomplish that. The other thing to point out is that we are going to need one of our quantifiers. The idea here is that we want to look for a pattern one or more times consecutively, and then we will need to use the plus sign. Now, there is technically another way to go about doing this, or actually a couple of different ways to go about doing this. So I'm just showing you one convenient option. As you explore regular expressions, you might discover a pattern that makes more sense to you, or even arguably a better pattern. And so what we want to do is we want to look at a couple of different ways to capture an IPv4 address. And so to begin with, we're not going to be using the output of a system command or a text file. Instead, for this particular example, we're just going to hard code our local loopback IP address, adapter address of 127.0.0.1. Now, I'm going to intentionally leave off the semicolons because that way we get a little bit of noise in our command window that will help us as we're going along. And we'll start off with our IPv4 address. We're going to capture and store in a results variable the output of the regexpi function. Before we go any further, I want to take just a second to remind everyone about the help function in MATLAB that will actually pull up then a local version of the help, complete with the table that I just showed you on the internet. Again, it's perfectly fine, whichever version of this you use. But we want to start off by trying to parse our IPv4 address, and we're going to look for a /d or digit. Now, the /d by itself is just going to look for and match the pattern of a digit. It is not, in fact, going to store or capture it. In order to do that, we actually need to put parentheses around whatever pattern we actually want to capture. And I'll see a little later in this video that sometimes you actually do explicitly want to ignore certain parts of your pattern and only focus in on capturing the octets themselves. And you'll see what I mean in just a second. And then the last thing that we want to do is we actually want to go ahead and capture the tokens or the results of the pattern matching capture. And so let's see what we get here. If you run this line, you'll see that I get a 1 by 6 cell array, and we'll start by taking a look at the individual results, starting with results, curly braces 1, and that returns the number 1. And notice now I have it enclosed in single tick marks to indicate that it's the character 1. We'll talk about that in later videos and how to transform that into its numeric representation. Then we look at results curly braces 2, and we get the second element in that array. The results curly braces 3 gets us our 7, and results curly braces 4 gets us our 0. And by this time, you've probably figured out that effectively what I've done is I've picked out each of the individual digits in the IPv4 address. That's not exactly what we wanted to do. And so in general, what you do when you're trying to discover the appropriate pattern is you sort of build it piece by piece. And to see what I'm talking about, we're going to add a plus sign to our /d, which indicates that we are then going to capture one or more digits. And so if we rerun this, you'll see that I now have a 1x4 cell array. And if I do results curly braces 1, you'll see that I've captured the entire 127. If I do results curly braces 2, there's our 0. Results curly braces 3 gets us that second 0. And then lastly, results curly braces 4 gets us that 1. And effectively what we've done is we've pulled out each of the individual octets. Now, we're going to come back to this in just a second because I want to show you a more explicit way of going about doing that. In other words, with a slightly better regular expression, because this particular regular expression is going to be too generic. It's going to capture any pattern of one or more digit. In other words, you probably don't want to do it this way. Instead, what we're going to do is we're going to continue by adding a period after the plus sign. And by itself, the period means that it is going to capture any character, including white space. And that's not exactly what we want to do. We want to capture a period itself. In other words, we don't want to capture numbers followed by a space or numbers followed by a letter. What we want to do is we want to capture numbers followed by a period. And the way we accomplish this is by, again, putting another slash in front of the period, which essentially says I'm looking explicitly for a period. And now you'll see that I have a 1x3 cell array. And that might be a little disconcerting because effectively we've lost something. And to see what we've lost, we go through and look at the individual elements in our results array. And you'll see that I get a 127 dot, a 0 dot, and then another 0 dot, but there is no fourth element in the cell array. Effectively, because there is no period after the 1, I've now lost it. But that's okay. Let's keep pushing forward with this. We're going to now add to our pattern another d/d plus. And if we rerun this, you'll see that I now have a 1x2 cell array with the individual results looking like a number, period, number pattern. And if we look at the results curly braces 2, you see that I've essentially split now our IPv4 into two pieces. If we were to follow this up again with a slash period, you'll see that I'm only discovering one piece of our IPv4 address. Basically, there aren't enough periods to go around. In this case, there needs to be 2 periods for me to be able to capture this second portion. Sorry about that. I accidentally drugged my text. And you are not going to match this pattern right here. So continuing on with that, let's add another /d plus to capture that third number. And I think at this point, you've probably discovered the pattern. So we'll follow it up with another slash period and another /d plus. And if you think about it now, we have numbers followed by a period, followed by numbers, followed by a period, followed by numbers, followed by a period, and then lastly, numbers, which is the IPv4 address. And so you'll see that we now have a 1-by-1 cell. And if we look at our results, curly braces 1, we have the entire IPv4 address. But I said we wanted to look at this a couple of different ways. And the second way is we want to actually look at the individual octets and be explicit about capturing them instead of just accidentally capturing any numeric pattern. And in order to accomplish this, then what we're going to do is we'll go ahead and do a second variable. We're again going to use our regexpi. There is technically a way of going about doing this using string split, but it assumes that you've already captured the entire IPv4 address. In other words, that there is no other text included. This will allow for us to capture and parse an IPv4 address into its individual octets. Again, we are going to use our IPv4 variable. We are again going to start off with the pattern of /d plus, but this time I'm going to push this slash period outside of the parentheses. In other words, I basically don't care about the period. I just simply want to get the value, the numeric value from 0 to 255 that is part of our IPv4 address. And I think you can guess here that I'm going to repeat the pattern again for the /d plus, again in parentheses, and I'm again excluding the period because I don't want that. And again, another /d plus for that third octet, followed by a period that has again been escaped. And then lastly, that fourth octet with a /d plus. And just like in the earlier example, I want to go ahead and capture the tokens. Now, if we run this, we're going to get a different result than we did with the earlier pattern, in that we are going to get this nested 1-by-1 cell with a 1-by-4 cell inside. And to understand how we would access this, we'll start off with our octets, curly braces 1, and you'll see that we get a 1-by-4 cell array or a nested cell array in which we actually have to drill down in using a second set of curly braces to access the individual elements. Now, technically, we could have done this approach when we were doing with the results, but in this case, we have to use the pairs of indexes to be able to access the individual elements in that nested 1-by-4 cell array. And so now you see that we have our 127. Let's take just a second to go ahead and put this into our script. So we have our octets, curly braces 1, curly braces 1, which is going to get us our 127. If we do octets, curly braces 1, curly braces 2, then we will get our 0. And just to confirm this, you'll see that we get our first 0. If we do octets, curly braces 1, curly braces 3, we are going to get the third octet, which is also going to be 0. And then curly braces 1, curly braces 4, which is going to give us then our 1, which is our fourth octet. In this case, with our 127.0.0.1, it's going to be the value of 1. Now notice again, these are still character vectors. In other words, you can see the single tick marks or single quote marks around the 1, indicating that it's actually a character and not the numeric value. In another video, we'll take a look at how we can translate then a character vector into its numeric equivalent, and then possibly use it in conjunction with our dec to bin function in Matlab to be able to convert then this numeric representation into its binary equivalent. So hopefully you found this video useful. As always, if you have any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.